Hi again, everybody. I'm Doc Harmon here with another edition of the Westchester Children's Museum Science Tuesdays. Now I got some questions for you. Have you ever pulled off a winter hat and your hair flies all over the place? Did you ever walk across a carpet and get zapped when you touch something really metal? Ever look at a lightning bolt and wondered what in the world made that happen? Well, they're all due to static electricity. Now first, I've got an experiment to show you. Then I'm going to show you what you need to do a couple of experiments on static electricity at home. And at the end, I've got a challenge for you. So let's get started. Now I'm going to show you two experiments that you can do at home by yourself. The first one requires only a balloon, a soda can, and something of a cloth nature like wool. I have a wool sweater, and I'm going to rub the balloon on the wool, builds up a static charge, a lot of electrons on there, and then I'm going to hold it close to the soda can. Whoops, there it goes. Now I bring it the other way. Soda can really likes my balloon. Is that cool or what? The next experiment does not use a soda can, but uses a strip of plastic like you get vegetables from in the grocery store. I'm going to take a pair of scissors and cut off about an inch from the end of it. And when I do that, it will actually make a plastic loop when we open it up. Don't need the scissors. When we open this up, it'll form a ring. Like that. Now we're going to charge the ring too. With my fingers, I'll go like this. So I'm building up negative charges on the loop, just like we have on the balloon. Now I'm going to try to fling this in the air. We have negative charges here, negative charges there. Negative charges repel each other. How's that? Is that cool? Well, now that you've seen a couple of things that static electricity can do, let's talk about what it actually is. It's the buildup of electrically charged particles called electrons on the surface of an object. Electrons have a negative electrical charge. In a minute, you'll see why knowing that is important. Now, the way electricity usually builds up is when two surfaces rub against each other. When you walk across the carpet, shuffling your feet, electrons transferred onto you, shuffling, build up a negative static electrical charge on your skin. And when you touch a metal object, which has no charge, there's a sudden discharge, a shock. If the room had been totally dark, you would actually have seen what looked like a miniature lightning bolt. Another basic electrical fact: objects that have opposite charge are attracted to one another. Remember the balloon and the floating plastic loop? I charged them both the same way, so each had the same negative electrical charge. And what'd you observe? They repelled each other, like trying to force two magnets together with a North Pole to North Pole and South Pole to South Pole. Doesn't work. Now think about the balloon and the soda can. The balloon had a negative charge, but not the soda can. So it was more positive than the balloon. What you observe there? They were attracted to each other. The can followed the balloon, just the opposite of what the plastic loop did. Do we see static electricity in everyday use? You bet we do. Even though it's a lot more complicated, copy machines, laser printers, totally depend upon the basic principles of static electricity. Now it's time for the challenge I told you about earlier. I'm going to show you how to make an instrument called an electroscope. Scope, of course, has something to do with seeing, telescope, microscope. And electro obviously refers somehow to electricity. I want you to see if you can observe an electrical effect. Here's what you're going to need. A glass jar, a plastic lid from a food tub, a pair of scissors to cut the center of that out to make a piece the same size as the jar. Also, you'll use the scissors to cut a hole, pierce a small hole in the center. You will also need some aluminum foil. Now, I want you to make 2 pieces, and by the way, they don't have to be this shape. My pieces are egg-shaped, but you can use square, round. The main thing is you have little holes poked in the top of each of those, and we'll see why that's important in a second. And the last thing you're going to need is a piece of copper wire. Now the bottom of it has a little hook that's going to hold the aluminum foil. The top of it is a spiral, and that is sort of like an antenna for the electrons we're going to put in. So let's put it together. Start with threading the copper wire through the top of the jar. It's going to be like this. Now I'm going to take a piece of Scotch tape and tape the wire on like that. And also you will be able, you will want to put another piece or 2 of Scotch tape to hold that on. But first we have to put aluminum foil on the hook. 2 pieces of aluminum foil go on the hook. Now we need a source of static electricity. You can use a PVC pipe. We've used balloons. Today I'm going to take a baster from the kitchen, no bulb. This is a plastic tube, and we know what happens when we rub a plastic tube on wool. And I'm going to go like this a lot of times, and what we will end up doing is holding this near this little antenna in the copper wire. Now, it's very hard to see, so what I'm going to do is I'm going to change the camera background so you can see better. Okay? Let's go. So did you see in the electroscope, the aluminum foil pieces carried the same charge and they repelled each other? Now before I leave you today, I'm going to let you in on a neat trick. If you've ever been near a storm and see lightning flash in the distance, count the number of seconds till you hear the thunder. Then divide that number of seconds by 5. That's how many miles away the lightning is. How do you count seconds? I say 1001, 1002, 1003. Some people say 1 potato, 2 potato, but that's a neat thing, and that's because sound travels 1 mile in 5 seconds. So, if you are successful with the electroscope, let me know at info@discoverwcm.org. So long.